Basic pump curve. The basic pump curve looks like this. They do get more complicated and look something like this. Don't worry, we're going to go through them step by step and start from the basics. Each type of pump has a different chart, and the data plotted on them also varies with the model. The first thing we notice is that on the main vertical y-axis, we have head pressure, and on the horizontal x-axis, we have the flow rate. Basically, the head is pressure, and the flow rate is how much water the pump can move. What do these charts represent? If we turned the pump sideways and connected it to a pipe, the pump is pushing the liquid horizontally, so there is no pressure, but the water is flowing at its maximum flow rate. As we slowly rotate the pump towards the vertical position, we see the flow rate decreases, but the pressure increases. That's because it's now pushing against the water and the friction. As we get all the way to the vertical position, there is zero water flowing out of the pump, but maximum pressure. That's because it's using all its energy to push against the water and hold it as high as it possibly can within the pipe. At this point, it's just spinning the same bit of water, which isn't good for the pump, so you don't want to run a pump like this in the real world. By recording the values during this elevation, we basically get our performance curve, although we will note that pump manufacturers don't test pumps this way as it's not practical. Head pressure. Head is shown on the vertical axis, and this is referring to pressure, so we often hear the term head pressure. We measure head in feet or meters, which doesn't seem correct considering we're talking about pressure, especially as you see the pressure gauges on the pump typically reading PSI or bar. The reason for feet or meters is that pump manufacturers only know how high their pump can push a liquid. They do not know which liquid your system will be pumping. And as each liquid has different properties, the pressure will vary depending on the liquid used, but the height it can be moved by the pump will remain the same. For example, we have this pump which can provide 150 feet of head. If we use it to pump water, the pressure will be around 54.25 psi, but if we use it to pump milk, then the pressure will be around 56.15 psi. Why do we need to know the head pressure? Pumps are usually used to move liquid to a higher region, so we need to ensure our pump can reach this elevation. As we pump liquid through pipes and fittings, friction will try to oppose the flow. This occurs from the walls of the pipe and also disturbances to the flow path. This causes pressure loss, which wastes the energy from the pump. The amount of friction depends on the liquid type as well as the materials and fittings used. Therefore, we must calculate how much friction or pressure loss our system will generate and ensure the pump we select can overcome this. Otherwise, we're not going to get any liquid out the other end. Flow rate. The flow rate is a measurement of how much water is flowing from the pump in a given time frame. This is measured in different units, for example, US gallons per minute, liters per second, or cubic meters per hour. For example, a system might be designed to move 2 liters of water per second from a holding tank to a process tank. Performance curve. This is sometimes referred to as the HQ curve, H meaning head and Q, which represents flow rate. The manufacturer will test each pump to obtain the performance data and then plot this on the graph. This will represent all the possible configurations between flow rate and head pressure, and we use this to check whether a pump will suit our needs. The performance curve will be different for each pump, and some will suit our system needs better than others. You will usually see that as the flow rate increases, the head pressure decreases. When selecting a larger centrifugal pump, as long as our system requirements are on or below the performance line, the pump can be considered. We can potentially use smaller impellers or variable frequency drives to better suit our requirements. For example, the performance curve for 2 large centrifugal pumps are plotted here. We need a flow rate of 30 GPM or 1.89 liter per second, and a head pressure of 70 feet or 21.3 meter, which is here on the graph. That means pump 2 can't be used, but pump 1 could be. Impeller size. With centrifugal pumps, we can often change the size of the impeller. The diameter of the impeller will change how much water can be moved, so on some charts you'll see multiple performance curves which give us the performance details of the pump for different diameter impellers. The size of the impeller will often be listed at the end of the line. For example, 30 GPM or 1.89 liter second for a 4.5-inch or 114.3 mm impeller gives us about 13 feet or 3.96 meter of head, but if we used a 5.5-inch or 139.7 mm impeller, then we would get around 22.5 feet or 6.89 meter of head. In some instances, our required flow rate and head pressure might fall between the two impeller diameter lines. In such cases, we can often machine the impeller down to the required size to get a better match. You should ask the pump manufacturer or a pump specialist to carry out this service. The performance of the pump then needs to be calculated.